All right, so now we're going to move on to solving polynomials. Today we're going to look at solving by factoring. It's a pretty logical extension of what you already know about solving quadratics by factoring, but with a couple of little differences, okay? So first off, let's talk about what the difference is between the zeros of a polynomial and the solutions of a polynomial. So functionally, the zeros and the solutions are kind of the same thing, but they are technically a little bit different, okay? So here's what the difference is. When you talk about the zeros of a polynomial, okay, you find zeros of a polynomial when you have a function like y equals 3x cubed plus 2x squared minus 1, right? So this is a function. It's got an x and a y in it, right? Or it could be x and f of x in it. And in this case, when you're solving these, right, you would look at the graph of this polynomial, whatever it happens to look like, you'd find the point where it crosses the x-axis. I'm just kind of making up what these points would be, right? And this would be the zero of your polynomial, okay? So that would be the zero of your polynomial. It's the point where this particular function crosses the x-axis. Okay, now the solutions of a polynomial are slightly different. The solutions of a polynomial are when you have a equation that's only got one variable. So when I plug in a number here for y, like say 0, right? And then I say, okay, now I've got this equation. It's just got one variable, and I'm going to solve it and figure out an x value that makes this true. Now, for this particular made-up example with its made-up solution, right, that solution would be x equals -3, because this is the x value that makes the equation equal to 0. So you could pull this from the 0 of the polynomial, so that would give you the solution. So you can find the 0 of a polynomial to find the solution of an equation, right? So they're very tied together, but not quite the same thing. Okay, so that's the difference between the zeros and a solution. But functionally, you can kind of view them as almost the same thing. Okay, so that's kind of just a key like vocab difference there to sort of be aware of. So how we're actually going to solve by factoring. Step one is make sure that your problem equals 0, because we're going to use the zero product property, and you can't use a zero product property if it doesn't equal 0. Step two is obviously going to be to factor the polynomial, right? And then just like normal, set each factor equal to 0 and solve. Okay, so let's run through a few examples. This guy here, this is a Gcf factoring. Don't forget that that exists. Okay, so common factor here would be 2x squared. And when I pull that out, I'm left with x minus 6. So then either 2x squared equals 0 or x minus 6 equals 0. And we solve this. We're going to get 0 and 6. Okay, and there are the solutions to this polynomial. Okay, so this would be considered solutions because it's an equation with one variable, not zeros because it's not a function. All right, this guy over here. So the first thing I want to do is get this guy equal to 0. So I'm going to subtract the 28 from both sides. You want to usually make sure that your leading coefficient is positive. Okay, and then from there, we're just going to try to factor this. This one, I know it's going to factor because it's on the page about solving by factoring, and it's got 4 terms. So the first thing that I'm going to check is I'm going to check and see if I can factor this by grouping. So I'm going to split it in half. Common factor between these two is an x squared, which leaves me with 3x plus 7. Common factor on this side is -4, which leaves me with 3x plus 7. So then I can factor out the 3x plus 7, and that leaves me with x squared minus 4. Okay, and then just make sure that you fully factor it. X squared minus 4, that is a difference of 2 squares. So we can actually factor this another step forward and make that x plus 2 times x minus 2. All right, and then set each one of these equal to 0 and solve. Be careful with these because I tend to see people make silly mistakes on these ones, right? You'd subtract the 7 from both sides and divide by -3. So our solutions would be -7/3, -2, and 2. And there's your 3 solutions. Cool. All right, this guy down here, first thing I'm noticing with this one is that it has a GCF of 5. So I'm going to start there. So I'm going to factor out that 5, and that leaves me with x to the 4th minus, what is that, 16? Yeah, 16 times 5, 40. Carry the, no, that's not right. 80 divided by 5. Wow, I can't do simple math in my head apparently. No, it is 16. Okay, sorry, it's 16. Great. Glad that I could divide that. Okay, so we factor that out. And then here, this is a difference of two squares, right? This is a perfect square. That's x squared squared, and that's 4 squared, right? So I can still do a difference of two squares. Square root of the front thing in the back front, square root of the back thing in the back, 1 plus, 1 minus. Okay, and then from there, this is also a difference of two squares. So I can take this guy another step farther and make that x plus 2 times x minus 2. Right, so we've got the 5. And then this x squared plus 4, that does not factor. Okay, so you can't break that down. A lot of people tend to try to rewrite this as x plus 2 times x plus 2. It's not, right? If you did x plus 2 times x plus 2, you'd get a middle term, and you don't have that here. So that's not going to break down anymore. Okay, so our solutions here, right, if I were to try to set this 5 equal to 0, 5 can't be 0, right? So like on this guy up here, we had a solution of 0 because it is possible for 2x squared to equal 0. That happens when x is 0. But on this guy, 5 can't ever equal 0, so that's not an option, okay? Now, x squared plus 4, that could equal 0, right? I'd subtract the 4 from both sides, square root, and that would give me positive or negative 2i. So that's a possible solution. And then from here, I would also have negative 2 and positive 2. And those are my 4 solutions to my polynomial. Okay, great. Okay, this guy here. So factoring this one, so this is sort of similar to how we took this guy and we sort of made it into a difference of two squares. So it's kind of like followed the same rules as a difference of two squares. We can kind of do the same thing with this one and a regular factoring. Okay, so even though this problem right here, normally when we factor, like I could do something like 9x squared minus 12x plus 4, right? Well, because this one has sort of the same setup where this is x to the 4th and then x squared, so like this is that squared, right? So we can sort of factor this in the same way. So I'm going to factor this the same way that I would if it was an x squared and an x. Just I'm going to have a little bit higher exponent. So 9 times 4 is 36. And then I need two things that multiply to 36 and add to negative 12. So negative 6 and negative 6. So I'm going to make this 9x to the 4th minus 6x squared minus 6x squared plus 4. Okay, so two things that when you multiply negative 6x squared times negative 6x squared, you're going to get 36x to the 4th, right? And when you add them together, you get negative 12x. Okay, and then I can GCF each half. So GCF here would be 3x squared, which leaves me with 3x squared minus 2. GCF here would be negative 2, which leaves me with 3x squared minus 2. So then this is 3x squared minus 2 times 3x squared minus 2. So this is actually a perfect square. Cool. All right, doesn't factor anymore, so I'm going to set this equal to 0 and solve it. So x squared equals 2/3. So x equals positive or negative square root of 2 over square root of 3. But then don't forget you have to rationalize this, right? So I'm going to multiply top and bottom by root 3. And then I'm going to get x equals positive or negative root 6 over 3. And that's it. That's my solution to this polynomial. Two solutions, actually. Not just one. Two. One positive, one negative. Okay, and then this last one here. So x cubed equals 27. Now, you may be tempted to look at this and say, oh, well, I can just take the cube root of both sides and get the answer that way. You can't do that. Okay, that does not work correctly here. You can sort of get away with that when it's an x squared, as long as you remember your positive or negative. But when you're dealing with cubes, you can't do that. So our first step is going to be get it equal to 0, right? And then we're going to factor that. That's a difference of two cubes, right? So my first term is, so it's first thing, matching sign, second thing, right? Where those are the cube roots of the two terms, right? And then first thing squared, opposite sign, product of the two things, and then plus the second thing squared. So there's my factored form of this. So from here, it's pretty obviously seeing that x equals 3. Okay, but this guy, we still have to solve. And anytime that you do a sum or a difference of two cubes, this is never going to factor. Okay, so you're not going to be able to factor this from here. So at this step, I'm going to have to do a quadratic formula. So opposite of b plus or minus square root b squared minus 4ac over 2a. So that's negative 3 plus or minus. It's going to be 9 and then minus 36. So that's negative 27 over 2. I can simplify that. That's 9 times 3, right? So I can simplify that, bring out the I. So it's going to be 3I root 3 over 2. Okay, so then there are my solutions. So I've got 3 solutions here, 2, 3. Okay, one thing to just remind you of, we talked a lesson or two ago about that fundamental theorem of algebra that says that when you have whatever your degree of your polynomial is, that is the most number of solutions that you can have. So when you have a degree of 3, you could have at most 3 solutions, right? And here we ended up with 3, right? 1, and that's 2, right? 1 plus 1 minus. Okay. This guy was a degree 4. This one we ended up with 2 solutions, but remember they were kind of double solutions because this was the same, right? So I just solved one of them, but if I'd solved the other one, I would have gotten the same answers, right? So there's technically 4. 2 of them are positive root 6 over 3, and 2 of them are negative root 6 over 3. Okay, this one should have 4 solutions, and we see that. There's 2, 3, 4. Okay, this one should have 3 solutions. There's 1 here, and then there's technically 2 here because remember it's technically when you square root positive or negative. So there's technically a positive 0 and a negative 0. They just both happen to be the same thing. So there's technically 3 solutions there. Okay, and then this guy is a cubed, 3 solutions. Okay, so when you're looking at these polynomials, that's going to be kind of what you're looking for. So it should always work out to be the right number of zeros.